We're going to get started with the last section, which is 12.6 vectors. And vectors, as you can see, are just different arrows. They have different lengths to them and different directions to them. So for the first one, it has us take a look at vector n. So notice we want to start with the endpoint. The first number is going left to right, so we want to end at this endpoint where the arrow is. So we start here, we're going to the right 3 and down 2. So since we're going to the right 3, that's going to be positive 3. Since we're going down 2, then that's going to be negative 2. And we just put these arrows around them, and that will be our answer. So if we take a look at vector n, always go left or right first. So it's going to left 1, 2, 3. So since it's going to left, we put negative 3. And then it's going up 1, 2, 3, 4. So we put a positive 4. And that would be our answer. And both of those are in component form, our final answer. If we take a look at these bottom problems, it says transform each vector as described. Write the resulting vectors in component form. So they want our answer in component form just like above. So to start off with, we're going to be using these same transformations from the last section. So if it tells us rotation, we're using these top ones. If it tells us reflection, we're using these bottom ones. So for this one, it wants us to rotate it 180 degrees. So we're going to go to a rotation of 180 degrees. We're going to use this matrix here, -1, 0, 0, -1. We're going to put that as our first matrix, and then this vector, we're going to put it as our next matrix, and we're going to go ahead and multiply those. So we type in matrix A. We're going to type in matrix B. And then we'll take A times our matrix B. And we get -4, -2. So that is our answer. But instead of writing our answer as a matrix, they want us to write it in component form. Okay, so then that will be our final answer. Make sure for the next one, rotation of 90 degrees and rotation of 270, that first matrix you need to use instead these matrices. Okay. This next one that we're going to take a look at, it says find the magnitude. Magnitude is just the length of the vector of the sum of each pair of vectors rounded to the nearest hundredth. So how we're going to go ahead and do this, you can kind of see they got us started, that we want to go ahead and find V plus OW, so the length of that. So how we're going to go ahead and do that, we're going to go ahead and take the absolute value of V plus W, which equals the square root of, and how they got this 4, they went ahead and added these two 2's together. So 2 plus 2 gives us this 4. Then 4 plus -3 equals 1. Then we go ahead and square them and take the sum of them. So 4 squared is 16, plus 1 squared is 1. So then we get the square root of 17, which the square root of 17, if we put that into our calculator, we get 4.1. Well, you can just round to the tens place. Okay, so then that is going to be the length of our line connecting this endpoint to this endpoint. Okay, which would make sense if we had a straight line from here to here, that would be 4. Since it has that angle to it, then it's going to be more than 4. Alrighty, this next one, they want us to take -2 times our vector v. So our vector v is 3, 1, so we're going to take -2 times that. Use our scalar multiplication, so multiply -2 times both of those numbers. So -2 times 3, we get -6. -2 times 1 is -2. And then we're going to just leave our answer in component form, and you do not need to go ahead and graph them. Okay. For this bottom section, it says find the dot products of the following vectors. So for these ones, they went ahead and got us started. That you're going to be multiplying the first numbers together. So 4 times -2 is -8, plus, and then you're going to multiply the second numbers together. So 7 times 5, you're going to get 35, and then you're going to take the sum of those. So -8 plus our 35, and we get 27. Again, we multiplied the first numbers, multiplied the second numbers, and then we took the sum of them. Just as a heads up, if any of these Fourier dot products equals 0, then what that means is that they are normal to each other, meaning that they are perpendicular to one another if you would make those vectors. So this one, since the dot product doesn't equal 0, then these, if we would make the vectors, are not going to be perpendicular to one another.